Welcome to this video on solving systems of linear equations by substitution. And if you look at the standard, it says to solve systems of linear equations exactly and approximately. When they say approximately, they're going with graphical views. Well, we're not doing that in this video. We're going with the exact method. So we're going to use substitution, which is an algebraic method of solving linear systems of equations. All right, why would I use this? Just kind of a silly example. It's not completely realistic, but I'm a pretty skinny guy, 85 pounds, and my buddy is 157, more of a normal weight. Well, twin day is coming up, and so we want to weigh the same. So I'm going on a weight increase program. He's going on a weight loss program. I'm going to explain this pretty quick, and then we're going to look at the detail of how this is all working. I'm going to go on a weight increase program. And so there's my equation. I started 85 pounds. I'm gaining 8 pounds per week. He is starting at 157, losing an unbelievable 64 pounds per week. All right, the way we're going to do this with substitution is we're simply going to put the equations equal to each other. And we're going to solve for x. We have eliminated the y variable. We're going to solve for x. And first thing I'm going to do is add 64x to both sides. 64x. I get 72x plus 85 is equal to 157. These zeroed each other out. Then I'm going to subtract the 85. Get that on this side. I have 72x left over here. I got 157 minus the 85. I believe that comes to 72. And then I'm going to divide by that 72 to get x completely by itself. 72, this works out very nicely to 1. And basically what I said x was weeks. So it's going to take 1 week for me to gain the weight to get up to a certain amount, the same amount that it's going to take my friend to lose 64 pounds in 1 week to get down to the same amount. Now what is that amount? We're going to take this 1 and we can plug it into either one of these equations and solve. And I'm going to take the simpler equation, 8x plus 85. I'm plugging the 1 in here for x, so it's 8 times 1 plus 85, and that leaves me with 8 plus 85, or 93. And if we plugged it in the other one, we'd get the same number. So in 1 week, under these processes or these diet plans, we're going to be at 93 pounds apiece. All right, and I use this concept called substitution. And let's take a look at what this substitution is all about in a little bit slower form. Solving systems of linear equations by substitution means to, what was I going to put there? Means to, algebraically. I almost forgot. Well, I did forget. Algebraically solve, and that algebraically is just a fancy word for saying mathematically, using math as opposed to, calculating the numbers, algebra in an algebra method, to solve to find the intersection by using substitution. All right, this substitution concept is, well, taking something that is equivalent and putting it in place. And, I looked on the internet, I was thinking about, like, I got a recipe, I'm making something with butter in it, and somebody says, hey, that's a lot of fat in that. So, of course, I was only 85 pounds, so I could use a little fat, but I want to substitute something in it that doesn't have as much maybe saturated fat in it. So I go to the internet and I find out that there's a substitute. You can use applesauce in place of it. Okay, so what I would do is any place in my recipe that I had butter, I would put applesauce. Well, it's a very similar concept here. And let's take a look at it. I'm going to start on the left side over here. I've got two equations, and it's a systems of linear equations trying to find the point of intersection. Both equations are in slope-intercept form. Well, that's more of a question. And in this case, they are. So it's easy. I can substitute to eliminate a variable. Substitute to eliminate a variable. And what I'm doing is I've got this y equals negative x minus 1. And it says that y is equal to that. So in this equation over here, I'm going to replace that substitute, just like applesauce for butter. If this is my applesauce, I can now put it in place where the butter is. So I put it in place of the y in this equation, and I still have the other part, and then I'm going to simply solve. All right. So I've gotten rid of the y variable. It means I only have one unique variable in this equation now, and it makes it easy to solve. I add x to both sides because it was negative x. I get 3x, and people get confused by that. There's like a understood 1 in front of that. And then I'm going to add 4 to both sides. I get positive 3 equals 3x. I divide by 3, and just like a minute ago, we get x equals 1. That is part of the solution, but I got to take that 1 and I got to plug it back into either one of these equations, and I'm going to plug it back into this one. So I get y equals, where it says 2x minus 4, I'm going to put y equals 2, substituting the 1 in place, just like applesauce for butter, and y equals 2 minus 4, or y equals negative 2. So what does that mean in terms of an answer? My systems of linear equations, the answer is the point of intersection 1, negative 2. That was my x and my y. Over here, a little bit more difficult because while this is in the slope-intercept form, this one's in a standard form of a linear equation, so it's a little bit more complicated, but not horribly. I got y equals this right here. So I'm going to take that and substitute it in for y in the other equation. Say it one more time, applesauce for butter. So I'm rewriting this equation over here, negative 4x plus 2y, but instead of y, I'm putting the negative 4x plus 8 in there. And then I continue the equation, equals negative 8. So a little bit more complicated. I've made the parentheses and widened it up a little bit because I got quite a bit there to put in. Now the first thing I'm going to do is distribute this 2. Notice it's a positive 2 or plus 2. If it was minus, I'd need to distribute the negative with it. So I got 2 times negative 4x is negative 8x, and 2 times 8 is positive 16. All right, and now I need to combine my like terms. I've got like terms on the same side of the equation. I just combine them. All right, now I'm going to start solving for x and getting x by itself. So I'm going to subtract 16. Negative 12x, that zeroes out. I get negative 8 plus negative 16 comes up to negative 24. And I divide by negative 12 here. Divide by negative. I don't like all these negatives, but got to work with it. Negative divided by negative is a positive. 24 divided by 12 is 2. That's a lot of people want to stop there. But we solve for the variable that we have, and then we plug in to find the other variable. Plug in to find the other variable, and the other variable in this case is the y. So I could go up here and plug it in here, but you can see that's going to be a little complicated, and it's not really going to, I have to work that equation around. So instead I'm going to plug it into this one. Y equals negative 4 times x. Well, we just came up with x was equal to 2. So I've got, let me simplify that. Negative 4 times 2 is negative 8 plus 8. Y turns out to be 0. And a lot of people stop there, but I need to write the answer in coordinate form. Coordinate form. And we've got 2 because the x comes first, and then the y. X and y. All right. Let's see, going on to the next one. All right, now we got a couple examples. I want to run you through, solve each one by systems of equations using substitution, just like we've been talking about. And I just want to highlight that you can pause this video at this problem at this time and try it, and then just see if you get the right answer based on my results. So I'm going to put these two equal to each other. They're both in slope-intercept form. Negative 6x minus 16 equals 5x plus 6. And I'm adding 6x to both sides. Adding 6x because I'm going to get x by itself. Combine it first, then I'm going to subtract 6 and get 11x equals negative 22. I'm dividing by 11. I get x equals negative 2. That's not my final answer. I need to plug that back in right here. And I get y equals 5 times x, which happened to be negative 2, plus the 6. So I got y equals negative 10 plus 6, y equals negative 4. That's still not the final answer. I need to put it in coordinate form, negative 2, negative 4. If you were to graph those two linear equations, I don't know exactly what they look like, but you know, something like this and something like that. And the equation, the point of intersection is what I'm finding. All right, I didn't have to show that, but I just kind of wanted to let you see that's what we're highlighting there, is where those two linear equations cross. All right, different example because these are not both in slope-intercept form. This one is, and it says y is equal to this. So I'm going to take that, plug it in for y in the other equation. So I've got 4x plus 5y, but I'm not putting y. I'm putting what y is equal to. So I got negative 2x plus 4 there. And then I'm continuing with this equation, which says that it was equal to 8. Now, as with the other example, I had to do distributive property. 4x plus, well, 5 times negative 2x is negative 10x. 5 times 4 is positive 20. I'm going to combine my like terms. I got negative 6x plus 20 equals 8. I'm going to subtract 20 from both sides. Negative 6x equals negative 16. That's not right. You were about to say something. Is negative 12, and I'm dividing by negative 6. So I get x equals positive 2 because they were both negatives. Now, that's not the end. As you're starting to pick up on, it's 2 comma something. Well, how do I find that other something? I'm going to plug this back in. I'd prefer to put it in here because this one's saying y is equal to whatever I come up with. So I got y equals negative 2x, but I got 2 for x plus the 4. All right, the x goes away when I substitute in for it, just like the butter's going to go away when I substitute applesauce in for it. Y equals negative 4 plus 4. This is convenient. It comes out to 0. Now I've got my solution to the systems of linear equations. All right, so that was substitution when they're not both in slope-intercept form. Here's another one. What's different about this one? Well, let's find out. Oh, neither of them are in slope-intercept form. So you know what it would be really helpful to do here? If we're going to use substitution, is to convert one of these to y form. I'm going to pick this one, and you'll see why in a minute because it's pretty easy to work with. I'm simply going to add x to both sides. I'd like to get it in y form, and you know what? That did it. That's now in y form. I can now use that substitution concept to plug in what it said y was equal to in for y. So I get 4x minus 7 times what we said y was equal to equals 3. A little distributive property. You starting to see a pattern here? Hopefully you are. A little distributive property. Combine my like terms. Negative 3x minus 21. You can see that you're really going to need to know your negative and positive integer rules. Adding 21 to both sides. I'm getting negative 3x is equal to 24. Dividing by negative 3. I'm getting x is equal to negative 8. It's not the final answer. Negative 8 comma something. How do I find that something? This is x and y. I take this x value and I plug it in for, I don't like either one of those equations. I'm going to skip right on over here to the one that I moved, or that I reworked one of the equations into, because that's the easiest one to put it into. I got y equals x plus 3. I came up with negative 8 for x. Y equals negative 5. Negative 5. That's my point of intersection. And one more example, and then you can do the U try. All right, again, you can always pause it if you want and see what I come up with. Neither of these are in y form. Which one looks like the easiest one to work with? If I do this one, I'm going to end up with a fractional number here, the coefficient of x, so I'm going to stay away from that one. It just looks complicated. I'm going to go to this one over here, and I'm going to rework this into slope-intercept form. So I got 2x plus 2y equals 4. I'm subtracting 2x from both sides. I get 2y equals negative 2x plus 4. Those were not like terms. I can't combine them. Some people want to call that 2x, but it's not. It's negative 2x plus 4. I divide by 2. And I get y equals negative 1x plus 2, or just negative x plus 2. All right, now I've got that in y form, and I can do a little substitution into the other equation. So I've got negative x minus 8, I'm doing this equation right here, times y. Well, y turns out that it's negative x plus 2, according to this. Oops, I was trying to do a star. Turned into a bow tie. Equals 5. All right, I'm going to do a little distributive property. I'm glad I have this example because I want you to see this minus 8. I can think of that as plus negative 8, so that negative is going with it when I distribute. That turns into negative 8 times negative x, which is plus 8x. That's a positive. Negative times positive is a negative. So that's what you got to watch out for. That's why I had this example with the negative when you're distributing. Combining my like terms, I've got 7x minus 16 equals 5. Add 16 to both sides. We're just solving equations. You see a lot of solving equations all of a sudden. Dividing by 7, x is equal to 3. Of course, that's not the final answer. It's part of it. Here's my answer we're building. It's x and y, the coordinate of where they intersect. What do? I plug this in. Oh, yuck, I don't want to plug in over there. I'm going to go right to this one that I solved earlier. Negative x. Negative, well, x was 3, right? Negative x. That could trip some people up. So it's negative 3 plus 2. Y comes out to negative 1. That's what we're putting right there. All right, I know that was kind of a long video, but hopefully you're getting it. You try these, and so you can pause this so you can write these down, bring them to your teacher. They've got the answers. They can quickly see if you're getting it right or if you're making any mistakes and show you where those mistakes are. Good luck with it.